Hi, this is Dr. Shoykat Majumdar. Under the basics of physics for diploma students, today we will discuss optical lenses. It is on the submodule 4.3 and it falls under unit 4 and the name of the unit 4 is light. Learning objective is to demonstrate fundamental knowledge and insight into physical optics and to be able to understand and solve problems related to the eye and optical instruments, lenses, their function and correction. When we say lens, first lens that come to our mind is magnifying glass. So using this magnifying glass, the small piece of letters in a paper, it is magnified and we can see it easily. Another one is if the sunlight is made to fall on the magnifying glass and bottom of this one a small piece of paper is placed. After a few minutes we can see the small piece of paper will be burned at a particular point because the parallel rays of light are converged using this. This is a convex lens. This is a convex lens. So this convex lens will converge the parallel rays of light to a particular point. If you place the light, if you place the piece of paper at a particular point, then it will be burnt. This is how we know this magnifying glass from our younger age. Another one is microscope. We know microscope it has many use in biological laboratory as well as in clinical laboratories also for finding out bacteria, cross sections in the laboratory, cross sections of different plants or animal cells, etc. So what happens? Lenses are placed here. Lenses are placed here. Its magnification may be 10x, 10 times, 20x, 50x, etc. So this using these lenses, the image is magnified. And we can see the magnified image better. Telescope. We know the name of the telescope. It is used to find different celestial objects in our sky, stars, planets. Using this telescope we can see it more clearly. So long distance object, tele means long, telescope. So long distance object can be viewed. That long distance object is very small, we can see by a naked eye. Using the telescope it will be enlarged, the size will be bigger. So this is the telescope. So lens is placed here. This is the lens. The Saxon telescope for finding out stars in the sky, in a clear sky. The camera, small pinhole camera. There is a lens inside it. This is a modern Canon camera. So here we can see the lens. This is the lens. So lens is used to get a good picture of the object. So depending upon the clarity as well as the magnification, the price of the camera will increase. If its magnification is more, then its price will be more. So it all depends upon one criteria is its magnification. What do these devices have in common? Image formation on lenses, ray tracing, these are the common. Today we'll study refraction, its background, converging rays, applications, characteristics, image formation through ray tracing, and exercises. First come to refraction. In our previous video lecture, we have discussed the refraction. Just a recapitulation of this previous lecture is light always goes through some things or mediums. The presence of material slows light's progress, interactions with electrical properties of atoms. The light slowing factor is called the index of refraction. Glass has refractive index N is equal to 1.52, meaning that light travels about 1.5 times slower in glass than in vacuum. Water has refractive index 1.33. That means light travels about 1.33 times slower in water than in vacuum. Air has refractive index N is equal to 1.0028. So it is not exactly 1, it is more than 1. So vacuum, its speed is maximum velocity of light, it is 3 into 10 to the power 8 meter per second. But in air, it is the velocity of light is reduced. That's why air, its refractive index is not 1, it is more than 1, 1.0028. So refraction of a plane surface, light bends at interface between refractive indices, bends more larger the difference in refractive index. This is air. We are considering its refractive index is 1.0 and glass its refractive index is 1.5. This is a normal line. So light is coming from this direction A and after refraction it is moving along B. So this is the incidence angle, this is the refracted angle. This is the refracted angle. So in a convex surface, this is a glass, this one is a convex surface. Glass is the medium where the velocity of light will be slow and air where the velocity of light is fast. So here light is falling, so this is the incidence angle theta I, this is the parallel rays of light. If we draw a normal, we are getting the incidence angle theta I. Now after refraction, the light is passing through this direction. This is making an angle of theta t, that is a transmitted light, theta t. Now fast to slow bends towards the normal. So theta I is greater than theta t. A convex surface is called converging because parallel rays converge towards one another. This is the axis of the lens. So they will converge into this point C. Now another type, if light is coming from this direction, that means from denser medium to the rarer medium. This is AR. So this is the incidence angle. If we draw a normal, so this is the, we know when light is coming from denser to rarer, it moves away from the normal. So theta I here greater than theta t. But here theta I, here theta I, this is the theta t, this is the theta t. So theta t is less, theta I is more. Theta I is more, theta t. It is bending towards the normal. Here it is bending towards the normal. Here it is bending away from the normal. That is theta I is less than theta t. Here it is away from the normal. From denser to rarer medium, it moves away from the normal. So theta t is more than theta I. So the surface, here it is, here the light is converging here. From this way it is converging towards the axis, it is also converging towards the axis. So the surface is converging for both air to glass rays and glass to air rays. Here you can see from air to glass it is converging towards the glass at this point C, towards this direction along the axis. It is going to converge on this glass medium. Here when light is coming from glass to air, that is, it is going to converge in the air medium along the axis. Concave glass surface. This is the concave glass surface. Now, if the parallel light is falling, then what will happen? Light is coming from rarer medium to the denser medium. If we draw the normal, then what will happen? Rarer to denser means it moves towards the normal. So theta I is more than theta t. Okay. So it is what happened? It is moving towards the normal. That means it is diverging. Here also it is towards the normal. That is towards the diverging. It is diverging. So a concave surface is called diverging because parallel rays diverge away from one another. In this case, light is coming from air to glass. Then come to the next. When light is coming from glass to air, this is a concave glass surface. So it is glass to air, that means light is coming from denser medium to rarer medium. So if this is normal, then what will happen? The light will move away from the normal. So theta t becomes more than theta I. So again it is diverging. So it may be glass to air or air to glass. For the concave glass surface, it will produce always diverging rays of light. That means again the surface is diverging for both air and glass rays and glass to air rays. C is the center of this concave glass surface. So lenses. Converging lenses biconvex. Convex lens always converging and concave lenses are diverging. So converging lenses are biconvex. This is one convex end and this is another convex end. So this is biconvex, has two convex surfaces. And diverging lenses are biconcave. Here one concave surface, another concave surface. These two are producing biconcave surfaces. So converging lens. This is a biconvex lens here. The focal point of a curved mirror was the image point of a distant star. That means if parallel rays is falling onto it, then these rays are converged and will meet on the axis, meet at a point on the axis of the lens. This point is known as the focal point. So this point is known as the focal point. So it is coming from this point, it is going out. They are coming from this, going out. So they are meeting at this point. This point is focal point. It is the same for a lens. The focal point of a converging lens is where the incoming rays from a distant star all intersect. That means distant star means if light is coming from sun is a star, it is apart from a huge distance, so it will produce. So parallel light is coming from sun, it is falling onto this one and it is meeting at this point. So this is the meaning of the distant star. All intersect a particular point, the point is focal point. A distant star is used to guarantee that the incoming rays are parallel. So distant star will produce parallel light. So for a lens, some few points we have to identify. So this concave part, or this is the concave from this end, but this is a convex lens, biconvex lens. So this convex lens, so this arc of this convex lens is a part of a sphere. This arc also part of another sphere. Okay, now if we draw a straight line from the center of the second sphere, the center of the first sphere, so this is the axis. This is known as the principal axis. If we draw another line from this point to this point, then we will say it as optic axis. So first one is the principal axis, second one is the optical axis or optic axis. This relation is the optic axis. Now if parallel light is made to fall onto this lens, that means light is coming from distant star, then first the light will converge at the point F or F dash. This point is known as a primary focal point. That means we are considering light is coming from left, parallel light is coming from left and it is meeting at point F dash. This is the primary focal point. F dash at the point is the point that is on the principal axis. Now this sphere, this arc is a part of a sphere and its radius is 2f. We can say it as r. So r is equal to twice the focal length. So from the optic axis to the distance of f dash is known as the focal length. So twice f is the radius of curvature. That means this convex part is a part of a sphere and the radius of the sphere is the radius of curvature. So twice f is the radius of curvature from this point, from the optical center of this one. Optical center is the point where the optic axis and principal axis are intersecting. So another point is secondary focal point. If light is coming from right hand direction, then it will meeting at point F. For this one, so for this convex part, this is the focal length or secondary focal point, and its radius of curvature is 2f. That means say r dash. Here it is r dash means 2f. Here r means also 2f. If these two spheres having same radius of curvatures, then for both sides r and r dash will be same, equal. We may consider it as r. Similarity to a spherical mirror, incoming parallel rays are deflected through the focal point. So this is the parallel rays. It is falling. The light is coming from rarer to denser. If we draw the normal, it moves towards the normal. Now it is falling onto this point of the convex lens. This is glass. This one is air. So light is coming from now denser to rarer, it is moving away from the normal, then it is coming to this point. For this ray also, it is coming to this point, they are meeting at the point F, and it is producing the focal point F, and from the optical center, this point F is known as the focal length. So this is a thin lens. Just as a ray tracing for mirrors in approximate and only acute to certain situations, the ray tracing for lenses is accurate only for what are called thin lenses. Thin lens means this thickness is very small. The thickness of lens is very small. So this is the first focal length, and this is the primary focal length, this is the secondary focal length. This is the distance of the focal point or focal length. This F dash is the focal point, primary focal point, F is the secondary focal point.